Hi students, so welcome to the next session 21. Now today I will discuss some application related to determinants and matrices, and by using determinants and matrices we can find the solution of a system of linear equations. That means they given that variables in the form of two variable equations or three variable equations. For that equations, we can find a solution by using the concept of both matrices and determinants. Now in this, you have to learn the systems of equations are two types. In that first one, consistent system or consistent equations. The consistency equations means the system of equations are said to be consistent. The system of equations said to be consistent if the system has a solution or its solution is one or more exist. Consistent equations means simply called as the solution or one or more exist. One or more means the more means it is up to infinity also. That is called a consistent equations. Next, inconsistent. Inconsistent equations or system we call it. The system of equations are said to be inconsistent if its solution does not exist. Solution does not exist. Does not exist, that means there is no solution. Means no solution for the system of equations. Two types of equations. The system of equation solution, one or more exists. More means up to infinity. One means unit solution. So more also means up to infinity, infinite solutions also. And that system is called consistent system. Inconsistent equations means system of equations solution does not exist. That means there is no solution for that. Such equations are called inconsistent equations or inconsistent system. Now, how to find it? But in this now in second PUC, the problems we discuss where maximum finding a unique solution models only in PU level. Now, how to find a solution for the system of linear equations by using matrix method. Solution of system of linear equations by using matrix method, or actually matrix inverse method we call it. By using matrix inverse method, by matrix method means inverse method we call another name. By using inverse of the matrix only we are finding solution. Solution means two variable means we take in terms of x and y. Three variables means equation in terms of x, y, z. Now the system of linear equations they given like this. For three variables means system of linear equations. Equations are named like this: a1x plus b1y plus c1z equal to d1. Second equation a2x plus b2y plus c2z equal to d2. Third equation a3x plus b3y plus c3z equal to d3. In the three variable equations means there will be three equations, and two variables there will be two equations. Now from this equations, we need to write into matrices expression. We need to consider first coefficient matrix. This A is called coefficient matrix. Why it is called coefficient matrix means we are taking in each equation coefficients of x, y, z. First equation coefficient of x, y, z is what? A1, B1, C1. Second equation, second row have take A2, B2, C2. Next, A3, B3, C3. Next, solution matrix. Solution matrix is here what? X matrix. It is clearly column matrix. I am taking it which contains the elements is x, y, z, column wise. And what left remaining? D1, D2, D3. That is the right side that I am taking B matrix. D1, D2, D3. Now I express like this A, X, B. From this we can write the equation now. X equation form, matrix equation AX equal to B. These are linear equations. I taken into matrices. This is a matrix equation. This is a matrix equation. What here? A into X equal to B. If you multiply A matrix and X matrix, compare with B matrix, we get again the same equations. Now this is a matrix method. From this we will find X matrix. X is a solution. X matrix is the required solution of the linear equations. Now how to find from this? Now we are using the inverse of the matrix. By using that only we are finding solution of the given equations. Now there is a two conditions when inverse is possible depending on that. Case 1. Now in this case 1, how to find case 1? If A is non-singular matrix. A is a non-singular matrix. Non-singular matrix means what? That A value is not equal to 0. When that is not equal to 0, then its inverse exists. We know already when inverse exists, it's compulsory is a non-singular matrix. When non-singular matrix, we can find a solution for these equations. Now we know already we taken the matrix equation like this. What the matrix equation? Ax equal to B. From this Ax equal to B, how to find X matrix? Because X matrix is a required solution matrix for the linear equations. For that we need to find X value, Y value, Z value. How to find X matrix? Here for X what is the pre-multiple? A is there. We need to find only X matrix means here we need to change the position. For that pre-multiply with A inverse on both sides. Pre-multiply A inverse on both sides. Now here A inverse into Ax equal to A inverse into B. Now according to associated law, we change the position. What? A inverse into A into X equal to A inverse into B. Here A inverse into A, we know already what? Identity matrix into X equal to A inverse into B. I into X will get X only. X equal to A inverse into B. Now from Ax equal to B, we got X matrix. How to find? The product of inverse of A into B matrix. And the combination of these two product only will get the solution matrix, that is X matrix. This is called the matrix inverse method because by using inverse of the matrix A, we are finding solution. We call matrix method or matrix inverse method also. Now clear this one? This is a matrix method. In this case, when it is possible to apply, when that A value is not equal to 0 means it is non-singular matrix. Ax equal to B. And Ax equal to B is a matrix equation for the linear equations. From that matrix equation, we are finding solution. How to find that equation solution? X equal to A inverse into B. Okay, you will get doubt. If A is a singular, what will do? How to check the solution for the consistency or inconsistency? How to check this one? Case number 2. Coming to second case. Case 2. If A is singular. If A is singular, that is that A is equal to 0. In this case, A inverse does not exist. A inverse does not exist. Means not possible. In this case, we are not able to do further any steps. We are not able to find a solution further directly like this. But we can check system is consistent or inconsistent. We can check solution possible or not possible like that. For that, we need to calculate. We calculate the value adjoint of A matrix into B. This matrix product will find out adjoint A into B matrix. Now in this, based on adjoint A into B value, For example, if adjoint A into B is not equal to null matrix, zero matrix, then system has no solution and it is a inconsistent. Inconsistent system. Statement, remember, when that A is equal to 0 is a single matrix, we need to check these values adjoint A into B matrix. If adjoint A into B is not equal to 0 matrix, system has no solution, means that solution does not exist. In that system we call it as inconsistent system. Inconsistent system. Now, if in case, if adjoint A into B, we got 0 matrix, then system either consistent or inconsistent, according to either solution, either according to it have infinitely many solutions or no solution. Here both can be possible according to this. If adjoint A into B is a null matrix, then system either inconsistent or inconsistent according to the system having infinitely many solutions or no solutions. If the system is consistent, we consider it infinitely many solutions. If it is inconsistent, we will take as a no solution. Means solution does not exist. These two conditions you have to remember. Adjoint A into B is not equal to null matrix, and system has no solution and it is a inconsistent system. Adjoint A into B is null matrix, then system either consistent or inconsistent according to the it have a infinite many solutions or no solutions. Second case, singular matrix. This condition I remember. It's a non-singular matrix. By using matrix method, we can find the solution. That is the solution matrix. What here? X matrix. Maximum we are doing from this concept 5 marks model, guarantee model by using matrix method only. Clear? Case 2, I have to remember adjoint A to B not equal to 0 matrix. System is inconsistent and has no solution. Adjoint A to B is null matrix, then system has consistent or inconsistent according to it has infinitely many solutions or no solutions. This is the system of linear equation solution finding by using matrix method. I will solve problems now for 2 variables and 3 variables also both. Concept remember everyone. Coming to first problem. Example 1. First we will discuss 2 variable equation. Solve a system of equations. The given equation is like this: 2x plus 5y equal to 1, 3x plus 2y equal to 7. From this we need to find the A matrix. First we have to solving matrix method by using matrix method. First we need to write 3 matrices compulsory starting only. First A matrix, that is coefficient matrix. Only 2 rows will come, 2 columns. First equation x, y coefficients 2, 5. Second equation 3, 2. Next we need to write x matrix. Here x matrix contains how many variables? Only 2 variables. Right side values is called B matrix. 1, 7. Now first, before doing matrix method equations, first we need to check that it is a non-singular matrix or not. For that, we need to find the A value. That of 2, 5, 3, 2. 4 minus 15. How much? Minus 11. It's clearly not equal to 0. Therefore, A inverse is exist. Now we will take matrix method. Matrix method, what is the matrix equation? Ax equal to B. From this, we will find X matrix. How to find X matrix? A inverse into B. Now, what is the A inverse formula? 1 by det A into adjoint A. Det A value we know, we need to find adjoint A. Adjoint A we know for 2 by 2 easily. How to find adjoint A for 2 by 2? Adjoint again I am telling it is a matrix, not determinant. Square, that's why square brackets are written. How to find adjoint A for 2 by 2? Interchange diagonal elements. Change the sign for non-diagonal. Okay? Here only you have to change the sign. Minus 5, minus 3. Now from this we can write A inverse matrix. Because to find X matrix, we need A inverse. B matrix already we learned. 1 by det A into adjoint A. 1 by det A value what? Minus 11. Into adjoint A what? 2 minus 5 minus 3, 2. Now we got A inverse also. Don't multiply inside this value. Later you can multiply. Now consider that X matrix. What is X matrix? A inverse into B. By matrix method only that we are taking. A inverse what? 1 by minus 11. There is nothing but minus 1 by 11 into what is the matrix? 2 minus 5 minus 3, 2. Into what is the B matrix? 1, 7. Minus 1 by 11 into. We know how to multiply this one. 2 by 2 matrix into 2 by 1 matrix. When product is possible, here number of columns equal to number of rows. If you multiply it again, 2 by 1, remaining rows and remaining columns. First row with first column. 2 into 1, 2. Minus 5 into 7, minus 35. Row into column means product, sum of product. Next, second row with first column. Further, one more column is not there. Second row with only one column is there. Minus 3 into 1, minus 3. Plus 2 into 7, 14. Minus 1 by 11. 2 minus 35, how much? Minus 33. Minus 3 plus 14 is clearly 11. Now we are dividing with minus 11 or 1. Minus multiply inside, minus 1 by 11. Minus minus cancel. What will you get? 35 by 11. Here minus 11 by 11. From this X matrix nothing but XY column matrix. 33 by 11 how much? 3. Minus 11 by 11 is minus 1. From this, X is 3, Y is minus 1. How to check these values are correct or wrong? Just resubstitute these values X and Y in these equations. If equations are satisfied, that X and Y are correct. Otherwise wrong. Just substitute, checking. How to check verification? X value 3 now, first equation. 2 into X, 2 into 3, 5 into minus 1 equal to 1. 6 to the 6 minus 5. So 1 equal to 1. Check for second equation also. 3 into 3, 9. Here minus 1 y value. 2 into minus 1 is minus 2 equal to 7. So 7 equal to 7. Correct only. That's why this is like to do for 2 by 2 matrix. 2 equations is given. 2 variable equations. 3 by 3 also same method only. But directly you want to get adjoint A. Adjoint A we want to find out which we need to find the cofactors. Then only we get.